Welcome to Roots Academy. Myself, Inayatullah, lecturer of mathematics. Student, in our last video, we discussed about derivatives, and especially in derivatives, we discussed the topic related to second order derivative, which is very important in second PC annual examination. In today's video, we discussed about application of derivatives, and in that topic is related to rate of change of quantities, which is very important for 5 marks in second PC annual examination. In part B, they will ask one question compulsorily from this topic, that is rate of change of quantities. Applications of derivatives, topic related to rate of change of quantities. Rate of change of quantities. 5 marks compulsory. We will ask one question from this topic. Okay, students, let us discuss the questions, or before we go to the questions, let us know the formulas which are very important in this topic. Needed to solve this kind of problems are formulas. First formula is area of circle. Student, in the symbol we use for circle. Area of circle. Formula is pi r square. Second formula, circumference of a circle. Circumference of a circle, or we call it as perimeter of a circle. 2 pi r, and obviously yes, pi is 22/7. Next, third formula is area of rectangle. Area of rectangle is length into breadth. Fourth is perimeter of rectangle. Student, perimeter is sum of the sides of geometrical figure. So rectangle has two parallel sides, two equal sides, that is 2 into length plus 2 times breadth. 2 lengths and 2 breadths will be there in rectangle. So its formula is 2L plus 2 breadth. Fifth one, formula is volume of a cube, that is B equals x cube, where x is a side here. X refers to side of the cube. Sixth is surface area of a cube, that is S is equals to 6 into x square. That's the surface area, that is equals to 6 into x square. 7 volume of a cone equals 1 by 3 pi r square h. Here r refers to radius, h is height of the cone. Height is volume of a sphere. Volume of a sphere. That is V equals 4 by 3 cube. Again here r is radius and pi is 22 by 7. So these are the formulas which are very important to solve problems related to rate of change of quantities. If you know this much formulas, easily we can solve 5 marks question. Now students, let us go to the problems and discuss one by one. The first question. The question is clearly given which formula we should use. The geometrical figures are clearly mentioned in the question itself. Then we will read the question. A stone is dropped into a quiet lake and the wave starts forming. And the waves moves in a form of circles. It is clearly given. This question is related to circles. At the speed of 5 centimeters per second, speed is given. At that instant, when the radius of circular wave is 8 centimeters, radius is given 8 centimeters, how fast is the enclosed area is increasing? See here, anything is changing, it is with respect to time it is changing. It is with respect to time. So whatever we are differentiating, it is always we should differentiate with respect to a time parameter. Let's say it is mentioned that it is circle topic, question is there to circle. So we will use area of circle formula. Because we should find area of circle. Solution. First, let us take what is given here. Given dr by dt. Speed means distance traveled by time taken. Here is radius divided by time. Radius with respect to time is given. That is 5 centimeter. dr by dt is 5 centimeter per second. And we should find when radius is exactly 8 centimeter. Find the rate of change of area when r is 8 centimeter. Is asking me to find. It's a very simple problem. First, directly take area of circle A equals pi r square. Is a formula to find area of circle. So let me differentiate A with respect to T. Where A as well as R both are dependent on time parameter. So both we should differentiate with respect to time. Differentiate with respect to T. What do I get? dA by dt is equals to pi as it is. Derivative of r square is 2r, then it is dr by dt, because r is dependent variable here. It is dependent on t. So again, I should differentiate r separately. Let us substitute the values here. 2 pi as it is. R value is 8 centimeter. What is dr by dt? It is 5 centimeter. So that's it. Everything is substituted. Let us multiply. Then 80 pi square units. Then this is the answer. Questions? Let us go to the second problem. Yet of a variable q is increasing at the rate of centimeter per second. How fast the volume to increasing when its edge is 10 centimeter long. Then let me read the question here. The question is an edge of a variable q. So here again, question is very clear. This question is related to q, and the variable q edge is increasing. Whatever the edge is given, that is increasing at the rate of 3 centimeter per second. Then what we should find? How fast is the volume of a tube is increasing? Increasing when its edge is 10 centimeter. So what is going here? Edge, let x is an edge of a cube. Let us consider that x is an edge of a cube. What is the data I have given? It is increasing, that is dx by dt is also with respect to time. That is 3 centimeter per second. Next, x value at 10 centimeter we should find. What we should find? It is asking us to find dv by dt. dv by dt. Volume of cube is x cube. Volume of a cube is equal to side power 3. X power 3. So differentiate with respect to t. Both are depending on it with respect to time parameter. So we will differentiate with respect to time. dv by dt is equals to derivative of x cube is 3x square. Since again x is dependent on t, dx by dt. Now the answer is the value of x is 10 dx by dt is how much? 3. Well, how much you will get? 10 into 3, 30, 30 into this 90 centimeter per second. 6 by and it is clear that the question is related to rectangle. What are the things given in the rectangle here? Yes, the given in this question is telling that the length is decreasing. Student, this is a symbol for decreasing at the rate of 5 centimeter. Next, the width. Then x is increasing, with y is length x is decreasing, with y is increasing at the rate of 4 centimeter. Here it is 5 centimeter. Now it is asking us to find the perimeter and area when x is 8 and y is 6 centimeter. So let us start solving this. Solution. Given dx by dt. So anything which is decreasing, that we should take it in negative. Now it is positive quantity. Since it is decreasing, I will write minus 5 here. Minus 5 centimeter per minute. And the width by dy by dt is 4 centimeter per minute. X equals to 8 centimeter. Y is equals to 6 centimeter. The first sub question is asking us to find dt by dt, and the second sub question is asking us to find dA by dt. That's it, student. Let us find one by one. First is perimeter. What is the formula for perimeter? 2 length and 2 width will come. This is the formula for perimeter of rectangle. So let me differentiate with respect to time. Differentiate with respect to t. Differentiate with respect to t. So what do we get? dt by dt is equals to 2 into dx by dt plus 2 as it is. 2 is a coefficient. Dy by dt. Let's substitute this. 2 into dx by dt is minus 5 plus 2. Dy by dt is 4. So how much it is? So it's minus 10 plus 8. Student, what is my dp by dt? dp by dt is minus 10 plus 8 is minus 2 centimeter per minute. This is the first sub question answer. This perimeter respect to time is minus. Now let us go to the second sub question. Second sub question is asking us to find dA by dt. Area of the rectangle we should find. And these conditions are given. The formula to find area of rectangle is student, two functions are multiplying here. Be very careful. Here, since it is addition, so directly differentiated. But here it is not like this. two functions. Obviously, both are dependent on t, but see, these two are functions. These two things are multiplied. Whenever two functions are multiplied in differentiation, we will use product rule. We will use product rule. Or simply we call that UVA rule. Differentiate A with respect to t. Not only A, it is with x as well as y also. So dA by dt is equals to, what is product rule says? It says that first function as it is. The next is plus second function as it is. Next is derivative of first function. This is the product rule concept. Let us substitute this. dA by dt is equals to, what is x? X is right. Yeah. How much is dy by dt? dy by dt is 4 plus y. Y is 6. Next is dx by dt. dx by dt is here, minus 5. 8 into 4 is 32. Students, so there is plus as well as minus to this. So plus into minus is minus. 5 of 30. Finally, I will get 2 centimeter per minute. This is my dA by dt. It's a very simple problem. Of course, you can easily score 5 marks. Centimeter. Very simple question. I will read the question. A balloon which is always remain spherical on inflation is being inflated by pumping in 900 cubic centimeter per second. It is 6 means cubic centimeter per second. In that case, we should find the rate at which the radius of the balloon is increasing when radius is 15 centimeter. Since all these problems, application of derivatives, we already enjoyed in our childhood life. Especially when we were in childhood life, we did this kind of problems. I think many times we forced that we need balloons, and sometimes already we got a balloon which is already filled with air. Sometimes we used to fill. So I already experienced not only this problem, the previous problems also. The circle problem, the rectangle problem, all these things we have experienced. But now we are studying. So this is the beauty of mathematics. So after a long time we are studying. Whatever we did physical experiment, now we are analyzing this. Okay, students, let us see what are the things are given here. He said a balloon which is always remains spherical. So problem is related to balloon. Here he said spherical. This problem is related to sphere. Here formula we can use here. What is given? Volume is given. Cubic centimeter is the unit of volume. Volume is given. Volume is dV by dt is given. Volume with respect to time is given. See, cubic centimeter per second with respect to time. Then next is find the rate at which the radius of the balloon is increasing. It's dr by dt we should find. When exactly we should find? When the radius is 15 centimeter. Solution. Given dV by dt is equals to 900 cc per second. Then R is equals to 15 centimeter. dr by dt. Very simple. problem is related to sphere. With the formula to find volume of a sphere, volume of a sphere is V is equals to 4 by 3 by R cube. Question, this is the formula to find volume of a sphere, or you can call it as ball, anything. Let us differentiate this with respect to T. With respect to T. And what do we get? dV by dt is equals to 4 by 3 by R cube. R cube, the unit of R cube is 3R square into dr by dt. Because again R is dependent variable. Finally, what do we get? This 3 and this 3 gets cancel. dV by dt is 900. 900 equals to 4 pi. R is how much? R is 15 here. 15 square R by dt. 900 is equals to 4 pi 15 square is 225 dr by dt. 4 into 225 is 900. 900 is equals to 900 pi dr by dt. If I do the cross multiplication, then for me dr by dt equals 900 divided by 900 pi. This quantity comes to the denominator. Now 900 and 900 gets cancelled. For me, dr by dt is equals to 1 by pi. So final answer, dr by dt equals 1 by pi. Student, this question is related to general concept, but still we enjoyed this kind of problems also in our childhood life. Definitely we have seen a person, we ourselves have experienced in our childhood life that we start pulling the ladder when the ladder was gaining, especially when the houses were constructed. So the problem is related to the concept. Let me read the problem. A ladder which is 5 meters long, leaning against a wall. The bottom of the ladder is pulled. Suddenly a person is pulling the bottom of the ladder. Then away from the wall at the rate of 2 centimeters. The person is continuously start pulling the ladder with the speed is 2 centimeters per second. Also asked is the height of the wall. Obviously, suppose the person is pulling the ladder, definitely the height of the wall will be keep on reducing. As the ladder is going away from the wall, definitely the wall height will decrease. So that's what he's asking. And when exactly we should find? When the ladder is 4 centimeters away from the wall, that time we should find. Is given, ladder height is given, it's 5 meters long, and its speed is given. Is asking us to find height, how fast is the height. Let's solve this. To solve this, let me draw a diagram. Because sometimes diagram helps us to understand the concept. Let us consider this is a wall. Wall. Y side is Y I will call student. there is a ladder. This is wall. This is the ladder. This is the ground. Yes. This is given 5 meter long. This is A, B, and C. So what happened here? This is the foot of the ladder. This person starts pulling towards him, then definitely the height will be reduced. Because this is height is y means this is x. This is the diagram. Then he has given AC 5 meter, BC is given, that is x, and x is equals to 4 centimeter. Okay. AB, we don't know. Let's find that AB. AB is considered as y here. This, we don't know what it is. So if we just compare this, we just see the diagram carefully. Let's right angle triangle. Triangle ABC, right angle triangle. So it starts with the help of the diagram itself. The figure, triangle ABC is a right angle this figure. Triangle ABC is a right angle triangle. Right angle triangle. Whenever we see a right angle triangle, then one thing which automatically comes in our mind, that is Pythagoras theorem. Isn't it? So what is Pythagoras theorem says? Says square of the hypotenuse is equals to square of the sum of the two sides. What is it? AC. AC is obviously 5 square is equals to what is AB? AB is y square plus BC is what? X square. Now student, this will call as equation 1. At present, let me substitute the values. Obviously, 5 square is 25 equal to y square plus x is 4 square. This is how much? 25 is equals to y square plus 16. Then let us first find y. To find y, this 16 I should shift to the left hand side. But now 5 minus 16 is equal to y square. Finally, my y square is equals to 9, which implies y is equals to the value of y is 3. Okay, how far the height is okay. dy by dt is asking us to find. Next is what given? What is given? Dx by dt is given. Dx by dt is 2. Dy by dt is asking us to find. Okay. Now, I will differentiate equation 1 because this is the only equation we are getting from this. Differentiate equation 1 with respect to t. What happened? Derivative of any constant Y square is the constant, its derivative is 0. Okay. Next, y square, derivative of y square is 2y dy by dt plus derivative of x square. Derivative of x square is 2x. Since x is dependent variable, dx by dt. What I will do, shift this dx by dt terms to this side. So minus 2x dx by dt is equals to 2y dy by dt. Now student, left hand side 2 and right hand side 2x cancel. Now minus x dx by dt is equals to y dy by dt. Do the cross multiplication. Minus x by y dx by dt is equals to dy by dt. Let me substitute the value here. Student, how much? Minus is this minus as it is. Then the x is how much? 4. Y is 3. Just know what? Y value is 3. Dx by dt is 2. That is dy by dt. Student, what is my final? Final dy by dt is 4 into 2, 8 minus 8 by so it's a very simple problem and it is a general problem. What is saying that there is a particle which is moving along the curve and the equation of curve is given. In the equation of curve. Now after that we should find the points on that particular curve. We should find the x and y at which when exactly we should find when y coordinate is changing 8 times as fast as x coordinate. This point we should find our coordinate points x and y. Solution. Given 6y is equals to x2 plus 2. This will not as equation 1. Then again one more thing he has given. Y coordinate is changing 8 times as fast as x coordinate. Question, let us start differentiating this first equation 1. Differentiate equation 1 with respect to x. I will write here. Then the purpose of writing differentiate equation 1 with respect to suddenly x here is because it is given. Y is changing with respect to x. Is changing with respect to x here. So that's the reason I am writing differentiate with respect to x. What do I get? 6 times of dy by dx equals to 3x square. The derivative of 2 is constant. 3 one time, 3 2 times. So 2 dy by dx square. Finally, dy by dx is equals to x square. Next step, I write here. Differentiate equation 2 with respect to x. What do I get? dy by dx is equals to 8 because derivative of x is 1. Here both are dy by dx. Both are dy by dx. Just for your reference, we'll call this equation 3. This is equation 4. Right here itself. From equation 3 and 4, what we can say from these two equations? We can say that x square by 2 is exactly equals to 8. X square divided by 2 is exactly equal to 8. X square is equals to 16. X is equals to square root of 16, that is 4. Since he is asking us to find point, but the x I got, let us find y point. For x is equal to 4 in equation 1. Why purposefully in equation 1? Because curve equation is a condition. You cannot substitute here. You must substitute the x value in this equation only. That this is a curve. X is equal to 4 in equation 1. Then what do we get? 6 times of y equals 4 cube plus 2. How much is 4 cube? It is 64. 6y is equals to 64 plus 2. 6y is equals to 66. Which implies y is equals to 66 by 6. That is equals to 11. What are the points? X comma y equals 4 comma 11. Students, final points are 4 comma 11 because x is 4, y is 11. Question. I'll read the question. Since a student or a person is doing some experiment, and the experiment is pouring a sand from a pipe. Sand is pouring from a pipe. Then if he is pouring sand from a pipe, then he is getting cone shaped diagram. He is getting a cone shaped diagram. And the volume of the cone is given here 12 centimeter per second. Volume of the cone. Such a way that the height of the cone is 1/6 of the radius. So, what is the relation between height and radius of this cone? Is the height is always here 1/6 of our radius. In that particular case, we should find how fast the height of the sand cone is increasing. How fast the height of the sand cone is increasing when height comes to 4 centimeter. That's what he's asking. With the help of all this data, let us find the solution. First thing is dV by dt is given is 12 centimeter per second. The next is what? Height of the cone is 1/6 of radius. Of radius. This height is given. It's 4 centimeter. What is asking us to find? It's asking us to find dH by dt he is asking us to find. With the help of this data, we find dH by dt. And the problem is related to 1. What is 1 of 1? 1 of 1 is V equals 1 by 3 pi r square h. So this is the formula. And since before we go to the differentiation, let me simplify this. There is a relation between height and radius. So with the help of this, times of h is equal to r again. This formula, there are 3 variables, v, r and h. Let me convert it into 2 variables. Here r value I got is 6h. I will substitute here. By 3 by 6h square into h. V equals 1 by 3 by 6 square is 36. Then h square into h. This is charge. 3 1 times, 3 12 times. So finally my V is 12 pi h cube square into h. It's h cube. Now I can differentiate this. Differentiate with respect to t. So what do I get for differentiate? dv by dt equals 1 by r with is h cube derivative 3h square into dh by dt. Let me substitute the values now. dv by dt is 12 pi here. D h is how much? 4 square dh by dt. Now student, what do we do? 4 square before that left hand side and right hand side 12 and 12 gets cancelled. Thing is there means 1 will be there here. 1 equals 3 pi 4 square is 16 dh by dt. 1 equals 3 into 16 is 48 pi dh by dt. So finally, dh by dt is equals to 1 divided by this 48 pi. I will do denominator. 48 pi is my dh by dt. Very simple question. Here in this question, there is a man whose height is 2 meters. This man is walking with uniform speed. Uniform speed means same speed without changing the speed. Same speed is maintaining, and the speed is 5 kilometers per hour. Away from a lamp post, and the lamp post height is 6 meters. Speed is given here. Lamp post 6 meter height. In that case, it is asking us to find the rate at which the length of the shadow increases. Length of the shadow increases. Whatever the data I have given, that let me try to write in a diagram. Solution. let us take this is a lamp post. Lamp here. What is the height of this lamp post? 6 meters. There is a person stand. This person start moving with uniform speed. And here is stop. Then his height is, let me take 2 meters. Height of a man. If a person standing here and the lamp post is there, definitely shadow falls here. The shadow is falling. It's complete shadow. Shadow. Okay, let me try to join these things. Students, with the help of this, I got a triangle. Actually, I got two triangles. A, B, C, D, and E. What are the things are given here? Not in the diagram. AP is given. AP is 6 meters. Lamp post. Then TE is given, height of the man. Let me consider this B to D is B to Y is D to C is Y. Then uniform speed dx by dt. From here it is uniform speed, it is x. Kilometer per hour. This much is given. Students, if I just see this diagram carefully, I'm getting two similar triangles. The first triangle, the bigger triangle is ABC. Similar to that, there is one more triangle here. That is DCE. DC or DEC. Or you can write EDC. So one can say that from the figure, triangle ABC is similar to triangle EDC. ABC similar to EDC. Then when I said it is the similar triangles, then let us use one of the property of similar triangles. Sides are proportional, isn't it? The sides of the similar triangles are proportional. So that is AP side next is this side divided by DE. That should be equals with DC divided by DC. Ratios of the five. Let us substitute the value here. AB is how much? 6 divided by D is 2. That is equals to BC is plus BC is equals to x plus y. DC is equals to y. BD is equals to x. BC is x plus y divided by BC is y. So let me try to cancel this. Do one time, two, 3 times. What happened here? Student, there I got 3 equals x plus y by y. Go to the cross multiplication and get 3y equals x plus y. I will shift this y to this side, becomes minus y. 3y minus y equals x. 2y equals x, the relation I got. Now this I should differentiate. Y part is the shadow. So we have to find dy by dt. Differentiate with respect to t. So as this dy by dt is equals to dx by dt. This is 2 dy by dt equals dx by dt value is given. It's 5. With this, like dy by dt equals 5 is just this 2 I cross multiply, or we can take divide 2 on both. Of that, we got finally dy by dt equals 5 by 2. If you want to get it in decimal, this 2.5 also. Okay, students, with this I will end today's video. And students, in today's video, I completed almost all the concepts of application of derivatives topic, which is rate of change of quantities. If you prepare for this questions or similar to these questions, definitely you can score 5 marks easily without difficulty. And students, most of the students feel that application of derivatives is a little bit difficult, but believe me, it is very easy topic. Easily you can score 5 marks with this. See, all the problems are very simple. Just we should memorize some formulas and some general concepts we should use. I hope people understood today's concepts. If you have any doubt in today's concept, you can put your comment in comment box. And students, if you are new to our channel, don't forget to subscribe. And to be helpful to the other students, so please share our videos and like our videos. Thank you.